Hi everyone, this is the third video of our series called Essential Skills for Mechanical Engineers. In this video, we are going to talk about piping design. Piping engineering is one of the most sought after fields in the oil and gas, petrochemical, refinery, chemical, power plant, steel, water, and pharmaceutical sectors. Piping engineering is a specialized branch of mechanical engineering that talks about piping and layout of equipment and process units in these facilities. Piping engineers have a lot of tasks to accomplish in their respective departments. They are responsible for designing the piping systems that carry water, steam, gas, oil, two-phase mixtures, waste or other fluid. They are involved in the design, erection, troubleshooting and all other aspects of the creation of these piping systems. Piping design engineers or piping layout engineers are piping professionals who design the piping network of the complete plant. Piping designing means deciding the overall plant layout, the equipment location, the plot plan, the pipe routing, the development of the 2D or 3D CAD models, and finally the piping isometrics. Broadly, piping design engineers perform a maximum of the piping design work scope. A smaller part is performed by piping materials engineers and piping stress engineers in a different manner. As piping engineering is almost 95% technical job, to become a successful piping engineer, one needs to have enough imagination, knowledge and willingness to learn. To become a sound piping engineer, you need to be excellent in observation, analysis, project management, written and verbal communication as well as drafting. Now we come to the top skills that you need to have in your resume if you want to become a piping design engineer. First is CAD. Piping engineering makes use of various softwares like Smart 3D, CADWorks, PDS, PDMS, AutoPlant and AutoCAD Plant 3D depending upon the scope of the project. As a beginner, you should be efficient in AutoCAD 3D modeling as well as 2D drafting and drawing. Second, you need to have knowledge of pipes, pipe fittings and piping components. Piping design engineers should be aware of the broad spectrum of piping and related items. This translates to different types of fittings, different piping schedules, variety of common piping materials, flange pressure class ratings, and various types of different valves and their functions. Third is piping stress analysis. It is the scientific or engineering study of all stresses generated in a piping system. Now, where does this stress come from? Piping stresses are generated because of some kind of loads or forces in the piping system. These forces and loads can be categorized into two different groups: primary loads and secondary loads. Primary loads are generated due to gravitational forces, internal or external fluid pressure, spring forces, relief valve discharge, pressure waves during water hammer or surge effects, etc. A large value of primary loads creates plastic deformation leading to catastrophic failure. Secondary loads are generated due to some kind of displacements imposed in the piping system, for example, thermal expansion, settlement, anchor movement, vibration, etc. Most of the time, these are cyclic in nature and normally results in fatigue failure. Fourth is pipe routing. Pipe routing is one of the most complex activities and the core of piping engineering for oil and gas, chemical and power piping plants. While pipe routing, the piping engineer has to comply with various engineering requirements like process requirements, accessibility, safety, constructability, maintenance and operational requirements. Fifth is piping support. Piping support plays a very crucial role in the proper functioning of piping systems. Pipe support carries the pipe weight with contents. To maintain the integrity of piping system, a pipe must be supported following a proper pipe support plan. Pipe support engineering is very crucial for the success of any project as an accurate and judicious selection of pipe support is required. Pipes as irregular space frames are not self-supporting, so they must be supported. Piping loads are transmitted from pipe to supporting structures with the help of pipe supports. Proper pipe support knowledge during the layout stage is advantageous. Then comes codes and standards for piping. All piping design engineers should be aware of important design concepts from relevant codes, standards, specifications, and guidelines. The more conversant with such documents the piping engineer is, the less time he will be taking for designing this activity. Seventh is process documents. All piping designers and engineers need to be able to read and understand one of the most basic process documents called P&ID, Piping and Instrument Diagram, or PEFS, that is Process Engineering Flow Scheme. Piping design engineer should know how to extract data from PID and use those in piping design. Throughout the complete detailed design phase, P&ID will be the master navigator of piping design. The eighth important skill is the knowledge of basic process variables. The design engineer must be well aware of the few basic process variables like pressure, temperature, flow, and level. Also, the instrumentation used to regulate or measure these variables are very important parameter for piping designer. Finally, it all comes down to piping layout planning. In simple words, piping layout planning is a matter of designing dimensioned routings from one point to another with the branches, valves, piping specialities, and instrumentation as indicated on the P&ID. Many other factors like interference, piping flexibility, material costs, pipe supports, operation and maintenance, and safety and construction requirements are needed to be considered. At Upskul, we have expert mentors who train these skills and help you get into your dream job. Thank you for watching. See you in the next video.